This is a quick video describing or showing a demonstration of how AWS IoT can be used to create a smart parking solution. The equipment that I'm using here are two Raspberry Pis. This Raspberry Pi is acting as the field area network gateway. This Raspberry Pi has connected to it a switch. This switch is simulating what would be potentially an in-ground magnetometer style NB-IoT connected parking sensor, determining whether or not a vehicle has occupied the parking space. This Raspberry Pi is representing a street dynamic display, which could be indicating the number of car parking spaces available in a particular direction or in this particular street. So this device is generating events which are being transmitted over MQTT to AWS IoT Core. It is also transmitting device state updates to AWS Core over MQTT. This device is subscribing to successful updates to the device state, and as a result will change the display number based on whether or not car parking spaces are occupied. Here we have the AWS console, where just showing some activity for this particular application. The devices, there are 5 car parking space devices. 4 of them, so 2 through 5, are simulated or virtual, and the first one here, Car Park 01, is a physical device, which is represented by the switch. So when the switch is pressed, this Raspberry Pi will transmit events and device state changes over MQTT to IoT Core. Those device state changes are published to this MQTT topic, car park, and as the events are generated, they will appear here in this console. This Raspberry Pi device, which is representing the display, is subscribing to this AWS topic. This is a standard topic per device. You can see here Car Park 01 is the device that we're looking at, and as updates to the shadow representation of this device are accepted, events will be published to this topic. So as the device state is updated in AWS by this Raspberry Pi, this Raspberry Pi will change its display to indicate the number of car parking spaces available. So this Raspberry Pi here, which has the sensor attached to it, is running software in this terminal. There's a script that is periodically checking the state of the device and then sending MQTT messages back to AWS IoT Core showing the state changes. And in the bottom window here we have the code that is running on the display device, which is looking for state changes and will update its display accordingly. So start these up. So here we've initialized the client and now it's waiting for updates. Let's generate some updates by starting this application up here. This will connect and then begin transmitting updates. And we can see the updates coming through on both screens. We can see the updates coming through here on the successful state change updates and also on the events that are being transmitted. And you can see here that the occupied is false. And the occupied is false in this screen also. Now, if I change the state of this switch, this LED will light, which is just something I've provided as a local representation of the occupancy of the car parking space. The switch is now closed, the light has come on, The events have been sent through as occupied is true. The display has subscribed to those events, and with a bit of luck we'll update to 4. There we go. So it's just changed the number of free spaces to 4. I release the switch. We can see here that the occupied has returned to false. Here the events are being received, and we can see that the occupied status has changed from true to false, and now the display is back to 5 spaces free.